My name is Charles Giardina, and I'm head of platform engineering at Airbyte, as well as a founding engineer. Today, I want to talk to you about a trend that has snuck up on me in the industry. And what I'm here to say is that the data engineer is dead, and the industry just hasn't realized it yet. Now, I know this is a somewhat salacious conclusion, so I want to take a step back and walk through how I came to this conclusion, and then wrap up by putting together a prediction for what I think is happening next in data engineering. So we're going to go back actually to last month. I was at the DBT Coalesce conference in New Orleans, and I got the chance to hang out with a bunch of data analysts and analytics engineers. And for the sake of this talk, I'm going to kind of group data analysts, data scientists, analytics engineers all into one group and call them data users. And so these are people who are using or cleaning data once it's already been loaded into the data warehouse. And I'm going to make that distinction from the engineers who are responsible for loading the data into the data warehouse, typically data engineers who, in this context, I'm going to refer to as data movers. So I was at the Coalesce conference talking to all of these data users, and the thing that blew me away is that, well, they usually knew what tool they were using to load data into the warehouse. They didn't know a whole lot more than that. And the reason that this is a big deal is that it tells us that there's already a clean interface between the data mover and the data user. So what do I mean by an interface in this context? In programming, an interface is the notion that you can declare what an object does without describing how it does it. So to pick maybe a more tangible example, think of the replicator in Star Trek. All you have to say is, computer, make me a martini, and a martini appears before you. This is an interface. Under the hood, you don't know if the martini is being made by science fiction energy to matter conversion, some robot arm, or even a human bartender. So an interface allows you to define a contract for what something does without actually having to know how it works. What I'm asserting in the context of the data industry is that we have already developed an interface between the data user and the data mover, and this has happened organically. The data users simply say what data they need and where it needs to go, and then the data mover makes it happen. For the rest of the talk, I'm going to refer to this as the data movement interface. And the key thing about an interface is that wherever you have an interface, you have the ability to replace whatever the underlying implementation is behind that interface. So in this case, you can replace the data mover with a tool that fulfills the same contract, the same data movement contract as the existing data movers. The other key thing to recognize is usually the hard thing in software is figuring out what the right interface or abstraction is over a behavior. But organically, data organizations have already developed this bifurcation. So this is a really big deal and an important cue from the market. Before we go further down the path of what's going to happen next, I actually want to take a step back into history and understand how we got here in the first place. And so we're going to actually go all the way back to the late aughts, where Hadoop had become this really cool thing. And this weird phenomenon happened where we got to the point where if you weren't using Hadoop for something, people viewed your company as not really being a real company. There's a lot more history to that, and we dive into this into a blog post that we're going to release later next week. We don't have time to go into it now. The key takeaway for this presentation is that the reason that the transition from ETL to ELT didn't happen earlier is because the single most used tool in the data movement at the time was ETL focused, which meant that the predecessor of the modern data stack relied on the person doing the extract and load being the same person who was also doing the transform. It was all done by a software engineer. About a decade later, you see data warehouses take off, and they really changed the paradigm entirely. Suddenly, someone who was not a software engineer, but knew some SQL and was motivated to answer a question, was able to transform and do analytics on data themselves. And so this catapulted the industry away from ETL and towards ELT, since the data mover and the data user were now different people. So now we're caught up to the present, where ELT is really the rising paradigm. And what this paradigm unlocks is a new higher level of abstraction on data movement. If you're familiar with the OC model, the conceit of HTTP and the application layer was that it meant you didn't need to be a networking expert anymore to move data between servers. The next step in that progression is that you don't even need to be a software engineer anymore to move data. Data users should be able to do it themselves. So I'm making a lot of big claims that the data engineer is dead, but empirically we can see that data engineers still exist. What I have shown, though, is that there is an interface that exists by which the data engineer can be replaced. And I think the state we're in now is that we're just fighting decades of momentum dating back to Hadoop. If you look closely at what data engineers are doing today, they're not writing custom ELT frameworks anymore, which is a really good thing that they're not, but instead they're setting up and operating ELT tools. As these tools get better and fully implement the data movement contract, they can be operated by data users instead, which is why I think the data engineer is a dead man walking. Now, hopefully I've convinced you of my thesis, because that would be just in time for me to play a little devil's advocate against that thesis and point out two places where I think the tooling really doesn't fully fulfill the contract yet. The first is around information security and compliance. So right now, the responsibility of security and compliance is sort of scattered between data engineers and DevOps teams, and maybe security teams as well. And these are things like making sure your data is only allowed to go to is only sent to places where it's actually supposed to go, and complying with various certifications like SOC 2 or GDPR, etc. Fundamentally, these are challenges that data users are not well positioned to solve. And so while I'm not aware of an ELT tool that is really nailing these responsibilities yet, it's not that hard to imagine that each of these data policies can be encoded or integrated into these tools. Think, for example, if Airbyte integrated into your Vanta instance so that all of your data pipelines were automatically documented for your SOC 2 auditor. Another particularly interesting area around security is data policies for where data is allowed to transit. For example, if you're moving data from your internal Postgres database into BigQuery, you don't ever want that data to leave your network. This is where a tool that supports a hybrid cloud and on-prem deployment scheme can give you the best of both worlds for a managed solution and great data stewardship. The second problem that I think isn't fully solved yet is incident management. Even the best tools break sometimes, whether they're from a vendor or built by an in-house team. So who's going to handle incidents when they do arise? For cloud solutions, I think the answer really does fall on support teams of the ELT products. They need to be technical enough to make sure that they can solve any problems that come up, and then present them in such a way that they become tractable to the data user. I don't think this is an easy problem to solve, but it's certainly doable. So I want to wrap up with a hypothetical. And I want you to imagine that I ask you to move a subset of your data from whatever accounting tool you're using, maybe QuickBooks, and ask you to put it in your data warehouse. From my experience talking to users and reviewing ecosystem surveys, I know that this request is going to put a knot in your stomach, because in the status quo, this sort of task takes a week of work, and that's not even including all of the security review process that's probably involved as well. In a world where data movement is powered by ELT tools instead of data engineers, we can get this task down to a matter of a few clicks, and with better security guarantees than what we have in the status quo. And when you remove friction to data projects or any sort of project, you really increase the pace of innovation. For example, how much further along would we be in self-driving cars or machine learning if all the data movement problems were solvable in the order of minutes and not decades? Making data move easily is going to accelerate the pace at which data and tech can solve really important challenges. And this is why this talk is not bad news for the humans who hold the role of data engineer today. Fundamentally, these are engineers with really valuable skills who will be able to shift into other parts of the modern data stack. And with the innovation that comes with easy data, we'll see the pie get bigger for the data industry. So in short, this postmortem is a positive sum outcome for data engineers and the data ecosystem. Appreciate you taking the time to listen to this talk. I'd love to hear what you think on Twitter, GitHub, so please reach out on social. And I look forward to continuing the conversation. Thank you very much.